You're asked to go ahead and show that the instantaneous rate of change is -1/9. And then you're asked to write the equation of your tangent line. Even if they didn't mention instantaneous rate of change, to be able to find the equation of your tangent line, you always need to use the instantaneous rate of change to be able to find your slope of your tangent line. So we need to do our IROC formula on our 1/x. So we go 1/x plus h minus 1/x, all divided by h. Now we need to simplify this down. So we need to do a common denominator, which is our x plus h times x. So you got to multiply the first fraction top and bottom by x. The second fraction top and bottom would need an x plus h. So then you should be able to write this as one big fraction up here on top. You're going to have your x, distribute through your -1 to your parentheses, and you get a negative x and a minus h. Over your denominator, still all divided by h. Now you'll notice our x's right here drop, so we get just a negative h on top over our denominator, but instead of dividing by h, which is h/1, we'll go ahead and multiply by the reciprocal. The reciprocal of h/1 is 1/h. Now you'll notice our h in the bottom drops with our h in the top. So we have this. Now we can go ahead and plug in our 0. If we would have tried to plug in 0 for h anywhere before this, we would have ended up with 0/0, which is indeterminate. But now when we go ahead and plug in 0 for our h, we would have an x times an x in the bottom. So we would have a -1 over an x squared. This is your slope predictor formula that finds the slope anywhere along this curve. We want to know our slope when x is 3. So we're going to take our 3 right here and plug it in. We get -1 then over 3 squared, or -1/9. Then you're asked to figure out the equation of your tangent line. Well, we just figured out our slope using our slope predictor formula, the IROC, and we got -1/9. But to figure out the equation of your tangent line, you also need to know a point. We know x is 3, so all we have to do is just plug in 3 into our function to get the y-coordinate, and we get 1/3. Then all we have to do is just go ahead and use our point-slope formula, since we have a point and a slope. Go y minus the y-coordinate of our point, equaling our slope, times x minus the x-coordinate of our point. And then all we have to do is just get y by itself. So we'll distribute through, add 1/3 to both sides, and we have the equation of our tangent line.